And hello, everybody, and welcome to today's one-hour WhiteHat Security webinar. My name is Jim Manico. I'm the Vice President of Security Architecture here at WhiteHat Security, and I will be your presenter today. And I appreciate all of you, and thank you for taking the time to join us. Today, I'll be speaking about the top 10 defenses for website security. The conference line is muted, so please send me any of your questions by using the chat Q&A box in the WebEx presentation. Your questions will be answered at the end of the session. It is my pleasure to have this opportunity to present to you, and with that, we invite you to sit back and enjoy today's presentation. Without further ado, the top 10 defenses for website security. So again, my name is Jim Manico. I'm the VP of Security Architecture for WhiteHat Security. This presentation is developer-centric, and my background is in web development. We're going to talk to you specifically about how developers can build more secure websites. So here are the top 10 techniques that we're going to talk about today: query parameterization, cross-site scripting defense, access control defensive patterns, cross-site request forgery defenses, authentication best practices, the forgot password feature, secure design, session defenses, clickjacking defense, secure password storage and other password defenses, and encryption in transit. These are some of the core defensive techniques needed to even begin to build a secure web application. So slide number 1, you've come all this way to listen to this presentation, and I'm going to start with four lines of code snippets, or in this case, 3 lines of code snippets, as the number 1 most important defensive technique. And this is, of course, query parameterization. This is a way to build placeholders in your database query statements and then bind untrusted data into those queries to completely and forevermore stop the threat of SQL injection. By far, this is the number 1 most important defensive technique that you can use to build a web application. And this is also relevant not only to the OWASP top 10, it's all relevant to real-world data and what is the number 1 threat facing your web application. Again, query parameterization is a technique used to stop SQL injection. It also helps in most situations give you higher performance when talking to a database. And this kind of abstraction, query parameterization, as we see right here, it's available in the PHP programming language. It's also available in C# and .NET. It's available in the Java programming language. Here's another example of query parameterization, even in the Hibernate world, specific to Java. Here we have query parameterization in Ruby on Rails, and here we have it in the Cold Fusion programming language. Cold Fusion, coincidentally, or interestingly, allows you to parameterize even database table names and column names, which we don't see in other languages. Here we have query parameterization in the Perl programming language. Perl is one of the oldest languages used to build a dynamic web application. Back in the day, it was CGI, and we called it CGI security. That has hence migrated or matured into web security. Even in Perl, query parameterization is available. In Perl, they use question marks as placeholders, and still, at the time of execution, you can bind your dynamic or untrusted data or untrusted variables into that query. And this is, again, the key technique available in any web language that is going to stop SQL injection 100%. Now, there are other defenses necessary, like input validation and different permissions you may set to your database, as well as a host of other defenses. But the key defensive technique that your developers need to know about is the query parameterization technique that we just walked through. If you can build queries in that fashion, very simple of a task, then you will have forevermore stopped SQL injection. Again, SQL injection, it's easy to find from an assessment point of view. It is very destructive once the attacker finds a SQL injection vulnerability. But it's easy to find in code as well. It's also fairly easy to fix. So if we can't build our queries in a parameterized way, I'd say all hope is lost. I've even seen some organizations that have done a pass of their code where they would just go through their code base and fix all SQL injection. That's not an unreasonable approach if this is a threat that's still a huge problem for your organization. So number one, query parameterization. What's number two? And at the OWASP Foundation, one of the places that I volunteer my time, pardon me for 1 second, we have the OWASP query parameterization cheat sheet to assist you with this information in an open format. So number two, threat number two, and defensive technique number two, we have cross-site scripting defenses. Now, I was hesitant to build this section. At first, I wanted to call it the output encoding section. Next, I wanted to call it the attack data diffusion section. Then I wanted to call it the XSS sandboxing section. The fact is that in order to really stop cross-site scripting, we need a series of different defenses. It's not just one technique. As we're going to find out, it's a combination of output encoding, input validation in some situations, sandboxing, parsing JSON in a very specific fashion to truly stop cross-site scripting. We need a host of different defenses to stop it in a complete, thorough way, and I'll go through all the material over the next couple of minutes. Now, cross-site scripting, first of all, this is a very serious threat. When an attacker is able to find a cross-site scripting vulnerability on your website, that allows the attacker to hijack the active session and take over authenticated accounts. It allows the attacker to deface the website. Document.body.innerHTML is a chunk of attack JavaScript that will let the attacker modify any portion of your website. Network scanning, undermining or undoing any cross-site request forgery defenses. You can redirect the user as an attacker, load any script, steal any data, and even start finding key up and key down events and have a full keystroke logger as a result of a cross-site scripting attack. So the point here is the damage we can do in cross-site scripting is so severe, we have got to take this seriously. And cross-site scripting is so difficult of a threat to find in a complete way across the whole organization, kind of like the cockroach of the internet. You stamp one down, another pops up. Because it pops up so much, I do see some organizations brush this under the rug, and I implore you not to. I implore you to take this seriously. So here's an overview of defenses needed to stop cross-site scripting. This is the whole thesis of what I want to talk about in this section. In certain contexts, if your untrusted data lands in the body of an HTML document, we're going to need to do HTML entity encoding at output time to stop cross-site scripting. And if untrusted data lands in HTML attribute, we need to do HTML attribute encoding, which is a form of more aggressive HTML entity encoding. If untrusted data lands in a URL's get parameter value, we want to do percent encoding, the URL encoding. If the user is submitting an untrusted URL to you, like suppose two of you are tweeting back and forth and someone tweets a URL to you, then Twitter would need to take that URL and make it linkable in a safe way. And it's actually kind of complex. You need to canonicalize the URL, validate the URL, avoid JavaScript URLs, and then properly encode that URL without breaking it at the time of rendering it as a link to a user. And for bonus points, you can use one of the different databases to verify that the URL is not a malware URL. So untrusted URLs are actually kind of tricky to handle. We may have untrusted data landing in a cascading style sheet context. We want to do good validation, hex encoding, and design this feature properly. We'll talk about that in just a minute. If you have an untrusted chunk of HTML, you may be using a rich text editor within your web page. They tend to submit their markup as a chunk of HTML. And how do you validate that? You can't encode. You can't do a simple regular expression validation. In the case of HTML that's untrusted, we want to use an HTML validator or HTML sanitizer like JSoup, Anti-SAMI, the PHP Purifier project, or the HTML sanitizer project from OWASP. Any one of these projects will parse HTML and strip out malicious JavaScript to avoid cross-site scripting. And we have other defenses that we need, like DOM XSS has special techniques like avoiding certain APIs. In some cases, we want to sandbox. There are a bunch of emerging technologies, like the iframe sandbox, that's going to help us. And then we want to parse JSON in a safe fashion. We want to avoid parsing JSON with eval, and we only want to parse JSON with formal methods like JSON.parse available in modern browsers. We also want to only put untrusted data in these safe attributes. There are 3 different basic kinds of attributes. There's the standard safe attribute list, which we see below. There's also a URL-based attribute, which is a special case. And this is the totality of what we need to stop cross-site scripting. And let me just walk through these different contexts. Here's untrusted data in a body context. Before we put the data in that HTML, before we put the untrusted data within our markup, we want to do HTML entity encoding. In this case, we have an untrusted data landing in an attribute. We want to do attribute encoding here. We want to do URL encoding in the get parameter context. We want to do proper URL validation. We want to avoid certain kinds of URLs like JavaScript URLs. We want to make sure this is a safe URL. We want to encode properly at the time of rendering. Here we have a cascading style sheet value context. In this case, we want to do CSS text output encoding. And more importantly, we want to validate this data very strictly, make sure it's the right structure, because even encoded cascading style sheet data will pop in certain situations. So we want to be really careful about putting untrusted data in this context. Here we have untrusted data landing in JavaScript variable assignment. In this case, we want to do JavaScript text encoding in both of these situations. And the key is, what happens to this variable after you put untrusted data into it? We also want to avoid certain APIs throughout the DOM. And then when we parse JSON, we want to use a safe JSON parsing method. We want to avoid parsing JSON by eval, which I've seen in many recommendations and many documents. Also, when using the jQuery programming language, there are many APIs in jQuery that require additional defense before you put untrusted data into these methods. In every one of the cases you see before you in jQuery, if you put untrusted data in these methods, it will just execute whatever you put into that method. So if that's a sink, if that's where untrusted data lands in some way, then they will all be vulnerable to cross-site scripting. And you want to use a tool like the jQuery encoder from Chris Schmidt to stop cross-site scripting deep within these different DOM contexts. And then we have a few best practices from DOM-based XSS Defense Guide. Again, avoiding eval unless you have a wrapper function around it. Avoid the HTML rendering methods like inner HTML. Only build dynamic interfaces with the safe APIs. Only put untrusted data in a quoted JavaScript variable. It's actually quite difficult to stop all cross-site scripting. And the point I'm trying to make is you want to use a combination, again, of output encoding, input validation, sandboxing, parsing JSON in a safe fashion, avoiding certain APIs within the DOM, and basically designing your client in a secure fashion. It is a challenge to stop cross-site scripting in a thorough fashion. And I invite you to look at the OWASP series of cheat sheets on this topic. The OWASP Abridged XSS Prevention Cheat Sheet, the OWASP Original XSS Prevention Cheat Sheet, and the OWASP DOM-based XSS Prevention Cheat Sheet. All of this knowledge is going to be necessary in order to really stop XSS, cross-site scripting, 100%. So moving on to our third topic is access control. We see 3 major attacks on an access control mechanism. We see a vertical access control attack, which is your standard privilege escalation. This is when you have a low-level user whose a series of attacks can execute administrative or higher-level functionality and cause damage to the application in some way. We also have horizontal access control, and we see this more often. This is a much more difficult threat to stop. We may have 2 users with the exact same role, but should I be able to edit your profile? Should I be able to make a transaction as if I was you? Should I be able to, say, edit your username? And even though we're the same role, the answer to that question is almost always no. So we need to be able to, even in the case where two users have the same role, we still want to be able to protect that user and protect the privileges of that user from other users. And last, we have business logic attacks, like abuse of a certain workflow or abuse of proprietary business logic. We're going to talk specifically about the first two in this section. So here we have permission-based access control. And what I mean by this is, in most web applications, the developer is coding to the role. They're asking questions like, if the user is an administrator, or if the user is a normal user, or if the user is a manager, then let them execute this activity. The problem with that is that you're going to need to change your code every time you change the permissions of your software system. Now, if you code to the permission, if you code to the feature, you can code it once and not have to change these individual endpoints ever again and push the rules to some kind of configuration system. So in this case, we're saying if the user has access to edit a specific article, can the user edit article number 37, for example, we will never need to code this again because we're coding to the feature that the user is trying to execute. We're not asking what role the user has. Now, maybe underneath the has access function, we may still do a role check in some situations, but all of the individual endpoints in code will never need to change again. This is often called permission-based access control, activity-based access control. It's sometimes called data contextual access control. But these are the kinds of standard API layers you're going to need to build a nice, robust, permission-based access control system. Here we see an access control chunk of code, an access controller, being used in both the presentation and the server-side controller layer. In the presentation layer, we're doing an access control check to see if the user is allowed to look at the log panel. And in the presentation layer, if there's a failure here, no problem. If the user is not authorized to view the log panel, then we just don't show the link. But in the controller on the server, if the user is trying to execute a feature like delete user that they do not have access to, not only will we not execute the feature, but this is a great place to add intrusion detection into your application. There is never a situation where a user should be trying to execute a feature on the server that they have no permission to execute. So this is an example where the user is most likely maliciously trying to access a feature that they shouldn't have access to. In that case, we may want to alert the administrator or take more aggressive action because it's potentially an attack. So here are some positive patterns I want to encourage you to embrace when building a secure web application. Code to the permission, not the role. This is an entitlement-based system as opposed to a role-based system. Centralize that access control logic into one or more core classes. Design access control as a filter, so every request is forced to go through your access control methodology. Fail securely. If your access control processing logic fails in some way, always fail in a way that denies access to your system. Also, apply the same core logic or same methodology to both your presentation and server-side layer. Make sure you have, again, one core system for access control at any layer, and make sure that only your server-side trusted data drives access control. I can't tell you how many times I've seen some cookie or some request parameter role equals admin that drives the whole access control mechanism, easily modified by an attacker. Also, you need grouping. When you begin to build access control with individual privileges and individual entitlements, you suddenly have a large number of things to manage, which is always a problem. So make sure you group privileges and you group users to make the administration of your system much easier. And also take your administrative features. The best thing you can do is isolate them into a completely separate application. Charging along, we have a good cheat sheet, the OAuth access control cheat sheet. This is a work in progress, just another open resource to get more information on this topic. So next, I want to talk about cross-site request forgery. We're a little bit less than halfway done now, charging forward. So here's a nice, simple any application that would want to transfer money from one account to another. Again, suppose you as a user, you're logged into your bank. And let's say you're logged into your bank on tab 1, and on tab number 2, maybe have been encouraged to surf the web to some malicious, evil website. That's a terrible thing that happens sometimes. So on this tab, suppose you have this HTML right here. So this HTML is a pre-filled HTML form that's submitting a transaction to your bank. It's submitting $1,000 and transferring it to a different account. And the key thing is, this form is submitted automatically by JavaScript at the bottom. So the user, the victim who sees this code in tab 2, does not need to take any action to execute it. Just by surfing to this page, this form automatically gets populated and executed and submitted back to your bank. So unless the proper defenses are in place, just by surfing to this page, this transaction will be executed against your bank. So we need to do something about this. We need to add some kind of randomness into our web application to assure that a standard attack like this will always fail. Again, the secret here is to add some kind of entropy, some kind of randomness, so the attacker cannot predict the structure of how to talk to your web application and transfer money in this case. There are really a few different kinds of defenses we want to use to stop cross-site request forgery. The primary and most important defense is a cryptographically random token. Again, randomness is your friend when it comes to cross-site request forgery. I see several other methods that don't depend on randomness, that depend on, say, margin policy, or they depend on some browser defense. I'm not a fan of that. I think that any good cross-site request forgery defense includes strong, cryptographically strong randomness. So here's how this workflow would work. At the time a user first logs into your web application, generate a cryptographically random value and place it in the session of your website. And then every time you go and build an HTML form or a sensitive feature in your application, grab a copy of that CSRF token from session and put it in your form. And then every time that form or feature is submitted, grab that CSRF token from the form and verify that it's the same as what you see in session. And if those two values match, let the transaction execute. And if for any reason those two features do not match, if for any reason those two tokens, the requested token and the server-side token, does not match, then reject the transaction. And this token should be unique for every session, for every user. And in Java, you'd end up using a function like the secure random class to generate that value. The other powerful defense that you can use to stop cross-site request forgery is something as simple as forcing re-authentication. You know, Amazon.com does this incredibly well. They're the leaders to re-authenticate in the e-commerce world. First of all, we all know that you definitely want to force a user to re-authenticate when they go to change their password. Anytime you see a change password feature, almost always require the old password as well. That's the same thing as re-authentication. So think of what happens as you use Amazon's website. You're forced to re-authenticate as soon as you go from the shopping cart to initiating the financial transfer. You're forced to re-authenticate whenever you try to ship an item to a new physical location that you've never shipped to before. You're forced to re-authenticate anytime you go to edit the user profile, especially credit card information. And the normal workflow of that application, you don't need to re-authenticate very often. It's only in these special edge cases that are very security-centric. And again, when you force your users to re-authenticate for sensitive features, you completely stop cross-site request forgery. Because if you launch that attack against a victim, they would hit that feature, they'd be redirected to a left login page again, and that attack would be stopped cold. So re-authenticating users at critical boundaries is a great defense to help you stop cross-site request forgery in some situations. And I'm going to move on to the next topic now. And we have a good cheat sheet written by Eric Sheridan, the OWASP cross-site request, forgery cheat sheet. It talks about these defensive mechanisms in great detail. So let's talk about authentication for a few minutes. And I'm going to talk from a relatively high level of fairly known defenses that any authentication layer must need. But first, let's talk about the problems that we see very often in an authentication, in a vulnerable authentication layer. You may have a weak password policy or just weak hard-coded passwords. There may be brute force vulnerabilities where the attacker can just try millions of username password combinations to brute force authenticating to the application. There might be obvious vulnerabilities for username harvesting. There may be a way for the attacker to fixate the victim on a specific session ID and then hijack that session fixation. There may be session IDs that are weak or predictable, that do not have strong random numbers or sessions that were created in a homegrown way, which makes it easy for the attacker to predict session IDs in some situations. There may be a password storage mechanism that's not secure enough. They may be using encryption instead of hashing, and so on. We also want to talk about a forgot password feature that has been built in a weak way. We'll look at some research about the best ways to build this feature. We'll also talk about session hijacking via XSS. We'll talk about all these on this list in this section. So first of all, the era of the plain text password as a single factor is dead. It hasn't worked well. It's not working. We're in an era where we really need to shift to multi-factor authentication. And I really see the cell phone, especially in consumer-centric services, I see the cell phone as being the key secondary factor. We see Gmail, we see Battle.net, we see so many even modern services either already supporting multi-factor authentication or shifting to it in some way. With the rise of the cell phone, you now have a great device for consumer services to support multi-factor authentication in a relatively cost-effective way. Here are some secondary defenses that are almost canonical when it comes to building a good authentication layer. Number one, your error messages coming out of an authentication layer, they should always be generic. The moment you say password is invalid or username is invalid, you're giving the attacker information about what is accepted and what is not in a particular login mechanism. So if you tell the user two error messages, username invalid versus password invalid, when you tell the user the password's invalid, you know what you're also telling them? You're telling them that's a good username. And suddenly it becomes very easy to harvest a large list of good usernames. We also have the brute force vulnerability, and my favorite control is account lockout. Account lockout after a predetermined number of failed login requests is one really surefire way to lock down your authentication layer in order to stop a brute force attack. And this is critical because it stops the attack cold. There are other ways to stop brute force. This is the one I prefer. The question becomes, how do you unlock this account? There are a couple different choices. You can force the user to call the helpline. You can automatically unlock after a predetermined amount of time, like after an hour, automatically unlock them. There of course, are a variety of other ways to handle this. But this is my favorite defensive layer used to stop brute force. And again, this came up before, but force reauthentication at critical boundaries is one of my favorite controls. If the user tries to edit their email address, they try to edit their profile. If they try to ship an item to a new address that you've never shipped to before, and of course, when they try to change their password, force them to log on again. It's a very powerful defense that's not used enough, in my opinion. I also want to make sure that on the server, you're enforcing the credential strength for passwords as well when you are using them. We have the OAuth authentication cheat sheet written by Owen Carey. This is a great resource, an open, free resource to give you a good guide to building a secure authentication layer. And so here's another breakdown of an authentication feature, the forgot password feature. And right now, how do most organizations do forgot password? They do it by an email reset link. You go to the website, you mention you forgot your password, they email you a link, you click on that link, and you're then allowed to reset your password. I really feel that's not a secure way to provide the forgot password feature. The problem is that email by default is an insecure transport mechanism. When you connect to public email services, you may have encryption between your browser and that email server, but everything between email server to email server is all plain text. So all of your email is plain text through internet routing gear, and still a potential weakness. Your threat agents are telephony companies and any employee there, and regardless, you have some of your email being transmitted in plain text. So when you're setting a password reset link over standard email to consumers, that's definitely plain text at different areas along the transmission between your servers to that user. So I just don't want to trust email as a single factor when doing forgot password. So this is from the forgot password cheat sheet from OAuth. It was originally written by David Ferguson, which I helped modify. And let's walk through forgot password that can be done in a very secure fashion. You see this workflow at a lot of big banks. So number one, ask for several identity questions up front. The last name, first name, account number, email address, date of birth. The more identity questions you ask, the more secure the system is. I usually see banks asking 2 or so identity questions. Also, make sure that this initial form has good lockout policy. Someone may try to brute force even your forgot password form to force a forgot password workflow. So make sure you're enforcing lockout here. So first, ask identity questions up front. Next, ask for 1 or more security questions. Most people I talk to prefer 2 security questions. 1's enough here. And again, these identity questions and the security questions is just to get you started. It's not enough to reset the password. After a user has entered the identity questions and the security questions accurately, we then email them or SMS them or have some kind of mobile application that generates a random token for that user. And email is acceptable here. If the attacker had visibility into your victim's email, he would only see the token. He wouldn't actually be looking at the form that has all the accurate information. Because after the user has entered all the identity questions and the security questions properly, they would then go to their email or mobile, grab the token that was emailed to them, put it in the form as the last form field, submit, and then they're allowed to reset their password. Let's review this one more time. First, the user needs to enter their identity questions, the more the merrier. Second, that user needs to answer 1 or more security questions. Then the user is emailed or sent a token out of band. Then the user needs to take that token and place it in the form where they, or the workflow where they entered in the questions accurately, and then the user is allowed to reset their password. Again, we're not making this up. This is the kind of workflow that we see at big banks. We see it European secure applications. We see it in some stock applications. We see it in other services that have strong security. This is how we recommend you do forgot password if strong security is your call. And there's a cheat sheet on this one feature alone. There's the OAuth forgot password cheat sheet here. Next, we're looking at session defenses. And folks, we're going to finish up this webinar in about 10 minutes. Thank you again for listening. So number 7, we're looking at session defenses. This is more standard information. I'm going to move through the next few slides fairly quickly. First of all, your session must be your session ID, it must be cryptographically random. By default, Java gives you a 20-byte session. That's a good starting point. You can easily jump this up to 20 bytes. You need a long, strong, cryptographically random session ID. And in general, I recommend you use your application server, your programming language's built-in session ID mechanism. Also, most session mechanisms store that session ID in an HTTP cookie. That HTTP cookie needs some very specific features. Number 1, it must be secure. When you have a secure session cookie, all that says is that that cookie could only be sent over an HTTPS, a secure transport. And that cookie will not be sent if it's an HTTP request. It doesn't magically secure your application. It just ensures that your cookies are only submitted over secure transport. Another cookie flag is HTTP only. The HTTP only flag tells your cookie that it cannot be accessed by JavaScript. This is going to help you stop certain classes of cross-site scripting. Now, the cookie will still work to verify that you're authenticated. The cookie will still be attached to every HTTP request out to that server. It's just not going to be accessible via JavaScript, and that will stop session hijacking variants of cross-site scripting attacks. Also, be sure to generate a new session ID at login time. This is to avoid session fixation. The session fixation vulnerability is when the attacker hits your website, you assign him a session ID, and the attacker can then put that session ID on a URL in certain cases and trick another user into fixating on that known session ID and then log in. Now the attacker has the victim's authenticated account. So every time a user logs into your system, invalidate the old session ID, regenerate a new session ID, and that alone stops session fixation. We also want to make sure that we support session timeout. Anytime the user is idle for 15 to 30 minutes, log them out by invalidating their session on the server. Anytime the user has been logged in for a long amount of time, say 5 to 8 hours, even if they've been fully active all this time, still log them out. That limits the life cycle of how long a user can be logged in, regardless of their activity. And last, support a logout button in the upper right-hand corner. I see some websites squashing the logout button more and more. As websites build more features into their web applications, they're very often tempted to bury the logout button behind some menu. I suggest you make that logout button prominent and easy for the user to see in the upper right-hand corner of your website. So there's a cheat sheet, the OAuth Session Management Cheat Sheet by Raw Files. Very, very detailed, elaborate cheat sheet worth reviewing. Next, we have Clickjacking Defense. Clickjacking is, of course, when the attacker frames your website into some evil, malicious website for the purpose of making your web page invisible but still clickable. So the attacker is trying to trick the victim into clicking on some entertaining website, and the victim, unfortunately, has had a website that they're logged into framed and made invisible and placed on top of that tempting website. So when the victim is trying to click on this tempting website, he's really clicking on, say, Gmail or some known web application that they're logged into, and they're tricked into clicking in certain locations of that web page without even knowing it. There are two main ways to stop clickjacking. The first way is to use the X-frame option header. This is, of course, the best defense. It's a native defense that's built into your browser. And what this says is when you put an X-frame option header onto your web page, you can limit other evil web pages' ability to frame your good guy website. So the two ways you can stop this framing is to do X-frame options denied. This stops anyone from loading your web page in a frame. The other way is X-frame options same origin. This says that only your domain can load portions of your domain in another frame. Now, the problem with X-frame options header, two problems. Number one, it doesn't stop some of the edge case attacks like cascading style sheet based clickjacking. There are some kinds of clickjacking that this is not going to stop. It's very esoteric, and the browsers will end upon this defense over time. But the other problem is that certain browsers just don't support X-frame options. Certain browsers, like older legacy browsers that your corporations may depend upon, they just don't support this header. In that case, we need to do a manual frame-breaking script that prevents. Here's an example of this below. This is a sample of frame breaking from Code Magi from August Detlefson that works in all browsers. This will prevent your application from being clicked on when it's invisible. It's not a perfect defense. Nothing around clickjacking is, but this is the best we have today to prevent your website from being maliciously framed. And there's a cheat sheet. It's missing. We're working on this now. We're working on the OAuth clickjacking cheat sheet as we speak. Thank you for that. And finishing up here, we have just a few more defenses we want to talk about. Number one, we have secure password storage. The goal of secure password storage is to make it so that even when an insider is looking at your ciphertext, he's not able to reverse it back to the password in a reasonable amount of time. That's a modest goal when it comes to building a secure password storage facility. Again, we're really trying to stop an insider from reversing your password storage mechanism. We also want to stop the attacker who's using SQL injection to get to the plain text or database-driven version of your passwords as well. Those are the two threat scenarios we want to avoid by doing a mechanism of this nature. Now, first of all, we don't want to encrypt a password. When we encrypt a password, that implies that we have the keys and we can decrypt the password. The goal of secure password storage, again, is that so even insiders cannot reverse this mechanism. Only the actual user can verify that they typed in the right password, but never reverse. That's, again, the goal here. So we're going to use hashing as the core. Hashing is a one-way algorithm, digest it's often called. It will take a hash will take plain text and convert it into ciphertext that's only going to prove, it's only a one-way variant of an algorithm for cryptography. So first we're going to do the one-way hashing, as we see in this algorithm. Second, we're going to add a salt. Now, rainbow tables up to about 14 characters are available on the gray or black market, or even in the good guide market for security researchers. And the problem is if you just use a hashing algorithm and you have a weak password, you can buy a rainbow table up to about 14 characters that can be used to quickly reverse a hash back to the password. So we want to use a per user salt, just another random per user value to make to make it more difficult to reverse the password. So at the time the user creates their account or at the time the user resets their password, we generate, say, a 16-byte random value to use as a salt. We take the salt and we add the password after it, and then we use a hashing algorithm. And preferably, you're hashing hundreds of thousands of times. You hash in a sequence. You see the iteration variable here. You hash and then rehash hundreds of thousands of times. I tend to hash about 500,000 times today, and I'll double it in a couple of years. This is to slow down the algorithm. The goal is just to make it very time-consuming and expensive for the user to reverse this mechanism. There are different standards that support this feature. There are other algorithms like bcrypt, which also help with password storage security. We need to do something more than just hash. We need to do something more than encrypt. And this is one mechanism that will help us do that. Some other password security defenses. We want to disable disable browser autocomplete. Here we have form autocomplete is off and input autocomplete is off. This will prevent every single form field from auto-completing or from storing critical data in the browser's autocomplete cache. We also want to make sure that we store passwords in a form as the input type is password. So when the user is typing in their password, we just see stars or asterisks. We don't actually see the password itself. And also make sure you're never putting the password in markup in any way. You should only submit passwords over HTTPS. You should never log them, and you should never need to display them in the HTML document. And there's a cheat sheet, the OAuth password storage cheat sheet. We just cleaned that up just a few days ago. So here's a nice open resource to help with this topic. And last but not least, we have encryption in transit. There has been so many problems with encryption in transit. There have been so many problems with TLS where older algorithms have been proven to be brute forceable in a reasonable amount of time. We have beast attacks. We have problems with CAs issuing certs when they probably shouldn't be. We had a case where one CA was issuing a root cert to a private business in a hardware security module, and this mechanism let them man in the middle any SSL for any major website, and we just have so many problems with TLS. It's something that you need to question. I'm going to leave it at that. So we have two services that I tend to use quite a bit. There's SSLLabs.com. This is a free service from Ivan Ritzik, which will help you verify the HTTPS configuration of a publicly facing HTTPS server. We also have the OWASP transport layer cheat sheet written by Michael Coates and many others. This goes through a series of best practices to help you as an administrator configure the HTTPS variant of a web server in a secure fashion as possible. There's also a really elaborate cheat sheet, the OWASP transport layer protection cheat sheet, which will walk over these different defenses in great detail. And that is it. Folks, I want to say thank you so much for taking the time to listen to the WhiteHat Security webinar. My name again is Jim Manico. I'm the VP of Security Architecture. If you are listening to this in recording mode, by all means, please email me. I'm happy to answer any questions about this presentation at any time. And I'll be also staying on the line. If you have any questions, you're welcome to ask me right now through chat, and I'll be happy to answer those questions right now. So I'm going to take a moment and look at chat and see what questions have come in, if any have. See if any questions have come in. Just one moment, please. And there are no questions that have come in, and that's fine. If you do have any questions, please just email me. I am jim.manico@whitehatsec.com. One more time, that's jim.manico@whitehatsec.com. We have a question. Please go ahead with that question. I'm ready. Those cheat sheets are all at the OWASP cheat sheet series. If you go to owasp.org, OWASP.org, you will see a link to the cheat sheets on the left nav bar. Click and have fun. Or just Google OWASP cheat sheets. Everything you need will be there. All the cheat sheets will be there. So what tools do I recommend for web assessment pen testing? Now, that's a difficult question, but with an easy answer. I would recommend WhiteHat Security Web Assessment Services. I know. But WhiteHat is a web assessment firm. I tend to recommend our services for that. And the next question is repeated hashing really for strengthening weak passwords? No, not at all. Repeated hashing is to make it slower for an insider to reverse your password mechanism. We recommend that you increase it over time because, indeed, computers get faster, and you have cloud services and video, graphic card cracking capability, which makes the need for stronger password defense mechanisms. And again, it's not about the policy of the password. It's just to make it more difficult for the attacker to reverse how you're storing a password. So suppose the attacker knows the salt, he knows the iteration count, and he knows your ciphertext of how you're storing the password. Like an insider who's a database administrator, how long would it take them to use those pieces to reassemble the password? He would need to take the salt plus the password and then do the hashing himself and see if he gets a comparison. And the longer the iteration count, the more different, the longer it's going to take to reverse that mechanism. That's why we do repeated hashing. And you see that repeated hashing also built in to different password storage encryption standards. So what's the difference between grouping access and role-based access? That's key. Keep in mind, my conjecture is that you don't want to code to the role. You want to code to the permission. So in your application, you will have like a series of permissions: edit article, view article, verify article, and you may want to have all of those different permissions rolled up into one particular permission supergroup, which is article administrator features. And then for article administrators, you can just assign them to that one permission. It's very similar to how you would do role-based grouping. It's just being done in a permission-based or entitlement-based access control mechanism. Are there any resources you can provide in securing server-to-server communication, i.e. database server to web server, internal systems, communications, and prevent attackers from communicating directly to the database server? So let me see here. We have the database server to web server encryption is what you're asking. Almost every database provides you with encryption transport mechanisms in terms of how you connect to that database server. Now it's very vendor specific. Every database supports it. There is a way to encrypt the connection between the web server and the database. I see a lot of companies try to do it and then roll away from that because it is a significant performance hit, and your database gets a lot of traffic is one of the other problems. So you can do it. It's vendor specific, but it is a huge performance hit. You need to test very rigorously before you roll such a thing into production. The last question I have here is there any reason to have both hardware and software firewalls on the same server? It really depends on your specific architecture. I can see having a hardware firewall for network security, and then maybe a software web application firewall like we see in F5 integration, or maybe a SWAP in mod security. There are many reasons where you may want to have multiple firewalls depending on your specific architecture. And folks, actually one more question. What's the most secure place to store encryption keys? The best thing you can do is not store encryption keys. There's a few other, there's key servers, there's specialized hardware security modules. There are a variety of mechanisms to store keys in a safe way. Most often I see people using operating system access control mechanisms to lock down access to a key. That tends to be one of the weakest ways to do it. One of the strongest ways to store keys is through a hardware key storage mechanism or some kind of professional key server. Very complex to use these technologies. There is no easy answer to that question. And folks, with that, I think we are done with this webinar. If you'd like a copy of today's presentation, please email us directly at marketing@whitehatsec.com. And again, if you have any questions about White Hat or White Hat services, you can also reach us at marketing@whitehatsec.com. WhiteHatsec.com. And folks, I want to thank all of you for your time today. Webinar attendees, if you have any questions beyond what we've done already, by all means, just email me at jim.manico@whitehatsec.com. And we'll have the link up to the recorded version of this webinar in about 24 hours. Again, thank you everyone for your time. Thank you for attending today's webinar. And code securely, build those secure websites. We need them in the current threatscape. Thank you again, everyone, and have a great day. And we're done. Cheers.
Hello and welcome to the walkthrough of the Sentinel online portal. My name is Justin Beechler. I am a solutions architect with White Hat, and I'm going to be taking you through the features and functionality today. To give you a little background on White Hat, in case you don't know, we are a web application vulnerability assessment platform targeting layer 7 or your application-specific vulnerabilities. To begin here, this is the executive summary page. This is the first page you would see when logging on to the interface. And what it serves to do is provide you with a 10,000-foot view of any applications that you have under assessment and some relative information as far as your general security posture. So on the left-hand side of the table here, we have a couple of demonstration applications set up in the interface here. And then to the right of that is a two-letter acronym in accordance with the service line that those applications are being assessed under. We have BE or Baseline Edition, SE or Standard, PE Premium, PL is Pre-Launch Edition. And to touch a little bit on each one of those, it really has to do with the comprehensiveness of coverage that you want on your application. So BE or baseline edition is going to be an unconfigured, unauthenticated assessment of your application. It's great for marketing sites, static sites, sites that you don't need to go too in depth, but it'll prevent against anything that an automated bot would find on the internet. SE or standard edition is going to give you a fully configured and authenticated assessment, looking for all the technical vulnerabilities. So cross-site scripting, SQL injection, anything from an automated perspective will be found with standard edition. PE or premium edition is going to give you the fully authenticated and configured automated testing that standard edition does, and in addition it will provide you with business logic testing. These are design-specific issues that are tested by hand, looking for authentication, authorization issues, session management, anything that a computer can't be programmed to do, anything that involves a judgment call is under the business logic scope. And then last is PL or pre-launch edition. This is our service line that's targeting specifically QA environments. It's got a very aggressive testing profile and real quick turnaround times. But the difference between the PL or the pre-launch and the baseline, standard, and premium editions is the production safety. Because PL is very aggressive with its testing, we do not recommend it for production applications, only for QA environments. However, the other three service lines can be applied to both QA and production environments. To the right of that is the industry rank. One of the benefits of assessing as many applications as WhiteHat does is we get the opportunity to compare you against all other companies within your same vertical. So taking the number of vulnerabilities found on those sites and comparing you to the other companies in that vertical give you an overall industry rank. The more vulnerabilities, the lower down on the industry rank you're going to be. Industry is something that you can set within the portal here and set yourself to financial services, IT, manufacturing, whatever vertical you believe you belong in. This will allow you to compare yourself to those sites. To the right of that is the findings, and this gives you a quick look at the number of vulnerabilities found, broken down by the severity or business impact. So here we have 16 urgent issues on this demonstration site, 27 critical, 15 high, 0 medium, and 0 low vulnerabilities. To the right of that is the scan schedule. This is one of the 3 key pieces of information that we need from you in order to begin assessing. One being the URL of the application, 2 being the scan schedule or the window of testing. You get to tell us when you want us to be assessing your application. We recommend 24/7. There are nights and weekends available and custom scan schedules. If you only want to have us test 3 hours on Friday and 4 hours on Saturday, that's completely within your control. The third piece of information that we need is testing credentials if your site does contain authenticated content. To the right of that is the scan status on the far right of the columns here. And this is a red light, green light system that basically alerts you if there's any action needed on your end in order for you to be getting full value from the service. As we can see, 3 of the sites here have a green light saying that a scan is running. We have a scan schedule, we have credentials, and we've got the URL, so we're all set to go there. If you were missing any one of those pieces, you would see a red icon here indicating that an action is needed on your side in order to be getting full value. Above there is a configuration in progress icon, and that's just simply letting you know that the Threat Research Center is hard at work configuring the site to get as deep and as wide as possible and really get that comprehensive coverage. Scrolling down below the table here, we see a lot of fun little charts and graphs. And this is really one of the benefits of having an annual subscription or an ongoing assessment is you get this trending information along with it. So from a month-to-month perspective, I can actually see, am I introducing more vulnerabilities? What month was that? Did I have a big, big code release that month? It gives you a lot of insight into whether you're getting worse or getting better with your security posture. Also, it gives you a lot of information about the vulnerability classes specifically. So I can see here I have 38% of my vulnerabilities are cross-site scripting. That's a good indicator for me that maybe my developers need a little bit of education as to why cross-site scripting is not a good thing to have, how to write secure code with cross-site scripting in mind to prevent against it. Scrolling back up here, clicking any one of your applications will allow you to deep dive into that application specifically and view a lot of this similar information, but on a per site basis. So you can see here the number of scans completed in the last 30 days for this demo site. The site priority. Now this is something that you can set in the settings option at the top here. And really what this allows you to do is assign a business criticality to the application itself. So if this is my flagship application, mission critical, I'm going to assign this to be a 9 or a 10. Whereas maybe one of my marketing sites that doesn't have as much traffic or focus on it, I'm going to put to a lower priority. When we view the findings in just a minute, you'll see that this site priority actually goes into the overall vulnerability score so that you get your most damaging vulnerabilities on your most critical business applications as kind of your top priority. To the right of that is the global and industry ranks. Global is essentially the same approach that we took to the industry rank, except now we're comparing you against all of the sites that we assess and not just the ones within your vertical. Scrolling down here, we have a lot of the same trending information that we had on the main page. This time it's for this site specifically and not for all of the sites. Scrolling back up to the top here, I'm going to open up the findings here. And the findings is the meat and potatoes of the service here. So some of the differences in the way that WhiteHat does things as opposed to your traditional desktop scanners is we like to organize our vulnerabilities into developer-friendly buckets. So what does that mean? That means if you've got a registration page that has a username and a password field on it, we're going to flag that as one vulnerability. Let's say they're vulnerable to cross-site scripting. One vulnerability for cross-site scripting, and we're going to flag each one of those parameters as an attack vector of that vulnerability. We figure that if developers are going in and fixing things, they're going to fix by page or feature set or form rather than by individual parameter. Each vulnerability is tagged with a unique vulnerability ID number that will never be duplicated, and it'll be there for the life of the vulnerability. So that's a great little reference point. Even if you were to fix the vulnerability and then revert your code and it closes out the vulnerability and then reopens it, it'll have the same vulnerability ID number. So that's a great little tracking method here. To the right of that is the retest. The retesting you can run on the fly, happens in real time. Any automatically retestable vulnerabilities will have a green check mark here. Any manually retestable vulnerabilities, so you talk about your business logic issues, things that can't be automated, you'll see a little hammer icon here that will indicate that that one has to be done by hand. But any one of these automatically retestable vulnerabilities here with the green check mark will run at the beginning of each scan of your application. So those will retest automatically each time. It's just for the business logic vulnerabilities. As you fix them, you can run in and retest these. A lot of this other information is pretty straightforward. When the vulnerability was found, the site that it was located on, the class of vulnerabilities. So here at WhiteHat, we operate under the WASC, or Web Application Security Consortium, class of vulnerabilities. And that's got all of your big doozies, your SQL injections, your cross-site scripting, content spoofing, insufficient authorization, session fixation. We hit all the big ones. To the right of that is the risk metrics. So when each of these vulnerabilities are validated by our Threat Research Center, they make a couple of determinations. One being the severity or business impact. 1 through 5, 5 being the most impactful. So we can see SQL injection here, obviously hugely damaging to a business. That receives the top billing at a 5 here. To the right of that is threat, and threat is ease of exploitation. How easy is the exploit to pull off? Again, 5 being the easy exploit, 1 or 2 being something a lot more difficult, would require maybe leveraging another vulnerability in order to make anything actionable happen. And then to the right of that is your site priority, and that's the value that you get to set that influences your overall score to the right of that. So severity plus threat plus priority gives you your score. The reason this is handy is because if you're looking at 200 vulnerabilities that you need to remediate, sorting by score gives you a great indicator of, okay, these are the most damaging attacks on the sites that I care the most about. So that's a great starting point. The far right column, details. That allows you to deep dive into each attack specifically and view some more information about that particular attack. So here we have cross-site scripting vulnerability. We can see here it was found on the datareceptor.php page. It's got all the information from the table that we just came from, retesting options, and then right below that is a little link called Ask a Question about this vulnerability. This is a great little link, widely utilized for vulnerabilities that are a little bit more complex in nature. What this allows your developers to do is click on this and open a communication dialog right below the parameters here with the security engineer that found this vulnerability. It allows them to ask for extensive exploitation steps, questions about remediation, pretty much whatever they want to ask. They can have a direct dialogue with the engineer. By default, we push a description and solution and references for each vulnerability that we find. 99% of the time, you're going to find all your answers within this section here. But for those complex issues, our customers have found that this Q&A session here is a great little benefit. Scrolling back up to the attack vectors. So in my previous example of a registration page, this would be like the username field or the password field. It'll show you the injection that we made. And for those of you familiar with cross-site scripting, you might notice that this doesn't look like a typical cross-site scripting injection. This is one of our production-safe methods here, as we use benign injections to test. Seeing this reflected back gives us a good indicator that there may be the existence of a cross-site scripting vulnerability, and our Threat Research Center engineers go in and they validate by causing an alert or a prompt to happen, and they will validate that it is an actionable vulnerability and push it to the interface here. If you want to see exactly what that looks like, there's a little details icon here, and you can dive into this one particular attack on this parameter and see, okay, what was the request being made, and then what was the response that came back. And we even highlight within the code where the injection is falling. Sometimes it falls in multiple places for your developers to kind of see what's happening there. Okay, moving on to the reporting tab here. We have a couple of different reports available by default. We have the executive report, which is going to give you access to all the pretty charts and graphs that we saw on the very first page. The site summary report is going to provide you that same information, but it's going to go a little bit more in depth as far as each site specifically, what vulnerabilities are in existence for those sites. Doesn't go into detail as far as what attacks were used or where the vulnerability was located. Just a brief, I have 5 cross-site scripting vulnerabilities, I have 6 SQL injections, etc., etc. Below that, the vulnerability detail and attack vector detail report. These are your developer-focused reports. This is going to give you all of that injection information, where the vulnerabilities are located, the descriptions and solutions that we saw before. All that information can be accessed on these reports. And there's a multitude of different filters that you can do if you want to do it only for the last couple weeks, for specific sites, for specific vulnerability classes, etc., etc. The last 2 reports available on the fly are the PCI report, which essentially shows PCI compliance and how you stack up against those different standards. And then Site Security Statement report is a really high-level security report. Who is WhiteHat? What do they do? What do they test for? How many urgent, critical, high, medium, low vulnerabilities do I have on my application? So this is great for third parties that are interested in what you're doing as far as security. This gives them a very basic understanding of what we're looking for and gives them that peace of mind. Touching on the admin tab here at the top, one of the benefits of Sentinel here is we don't charge per user. There's no limit to the amount of people that can have access to this information. You can set up your entire development team with access to Sentinel to view this information. You can set it up so that only your security team has access. Another great benefit of Sentinel is that all this operates on an open API. So if you have bug tracking systems like Jira or Bugzilla, WAFs like F5 or Imperva, GRCs like Archer, SIMs, whatever systems you're currently using in-house, as long as it can take that XML data, we can integrate with that. So for WAFs, for example, it can pull this vulnerability information into that WAF and set up those blocking rules specific to those attacks. So it's a very cool and powerful tool, the API here. As far as the users go, it's really setting up a new user is as easy as hitting the new button, filling out the email address of the user, and then assigning them access to particular sites, and even limiting the functionality they have access to. So you can give them a viewer-only role, a developer role, which has report generation and retesting of vulnerabilities. The security operator is going to give them everything that a developer has access to, plus it's going to give them the opportunity to change scan schedules and upload test credentials for the Threat Research Center to use. And then an administrator has full functionality, including this tab that allows them to add new users and adjust current user roles. Another thing to touch on down in the lower left-hand corner here is the email options. This is a great set it and forget it feature. If you don't want to be logging into Sentinel on a daily basis, this gives you the ability to have us alert you when we find new vulnerabilities based upon a daily, weekly, or monthly schedule. So if I were to choose the weekly option, every Monday morning that vulnerability was found, I'll get an email and it'll say, hey, we found 2 new critical vulnerabilities on your application. Here's a link to check it out. And it'll give you a link to the Sentinel interface here where you can log in and see that information. Also want to touch on the site management feature of the admin tab here. What's great about this is, especially if you have many different applications under service here, this allows you to group those applications under one big banner. So if you have, say, an e-commerce team that's responsible for 3 of your applications, you can create that group here and then drag any sites that you need to over to that e-commerce team. And then when you set them up access, you set up a new person with access to that e-commerce group, they then by default have access to those 3 sites. So it makes it very handy as far as organization of employees and sites. The last thing I want to touch on here is the support link in the upper right-hand corner. Accessing the support portal will give you access to our huge knowledge base, lots of information there, white papers, who's White Hat, what do we do, how do we do it, as well as a ticketing system that allows you to ask any questions of our support organization, make requests, suggest improvements to the interface here, do a multitude of different things within the interface here. So that, in a nutshell, is the run-through of Sentinel. If you have any questions at all, you can visit our website, WhiteHatSec, that's SEC.com. And feel free, you've got to contact us there, and you can email us with any questions or let us know. So thank you very much for your time, and have a great day.